Okay, so since we have a pretty packed agenda, I'm going to get us started. Given that it's Monday, you might not have seen the note well. Please note it well. You'll see it throughout the week. It's worth reading. We will need a minute taker and a Jabber scribe. Do we have any volunteers for Jabber scribing first? Okay, thank you, Linda. Is anyone happy to be Jabber scribe? There we go. Thank you very much. Thank you to our minute takers and thank you to our Jabber scribe. So the first thing we want to cover is a quick update on the charter. We discussed it on the list. We've discussed it at the last meeting and a number of meetings before that. We called rough consensus around the text that we posted on the list with the updates that we've made. You can see it at the URL there. It's currently an IASG review. We deliberately aimed to focus that on things that were making Spring technology deployable. I think we've got a bunch of the old documents around that we've worked on for some time where there's some operational considerations that we need to make sure that we cover and cover some of the gaps before moving on to other things. So that's been the aim of the charter to break down into those. We have, as a working group, a bunch of things that are ongoing. We still have documents that are somewhat dated that need to get through the standardization process. So, for example, the SRMPLS document still has some nits that need to be dealt with. We have a number of considerations around SRv6. There's still a significant number of security concerns around it, for example. And one of the blocks that was raised against the charter was actually on this subject. So I think this is some area that we need to have some focus on in the group. And then we have other supporting technologies, so some of which we'll talk about today, the OEM mechanisms for SR in general, and then Yang models supporting the kind of protocol independent parts of the configuration and telemetry for SR. Three considerations that I'd like folks that are working on drafts to look at. We have an interesting balance in Spring between documenting use cases and kind of functional specs, given that we've got so many kind of parallels with other working groups. So I think we need to make sure that the documents that we're producing are somewhat have the right balance between explaining a use case and the functional specification. We'd like people to think about whether collaboration with other working groups is required, and ideally which working groups, because we've got a number of documents where you'll see from the agenda there's overlap with, say, SFC, or there's overlap with the data plane technology groups. So we really should make sure that we're identifying those working groups early and engaging with the relevant experts in those teams. And then the one thing I could kind of note about a number of our docs at the moment is that they end up being stored for quite a long time whilst waiting for addressing open comments. So really, I think we need to make sure that we have sufficient time and we're not biting off too many different things to actually get things through the standardization process. So we have some other notes on the agenda. You will have seen from the mails on list, and there's a number off list, that we always end up with a very packed agenda. I think we'd like to start setting some expectations as to like what gets onto the agenda, and so we make the best use of the fact that everyone's sitting in the same place. We've had a few drafts which have had discussion on the list, but we continue to get kind of placeholder drafts or drafts that don't have any discussion on the list, then submit for an agenda slot. Please try and make send a mail to the list, have it more than here's the forwarded draft submission announcement. It would be good to highlight what decisions and discussion points there need to be for the draft. And I think we'll try and bias towards things getting onto the agenda based on having had some of that discussion and being able to address some of those decision and discussion points. As you're probably aware, there's an experiment around the agenda and slots for IETF 103, so that's going to mean that we also continue to have this problem. So the discussion that we're trying to bias towards in the agenda today, and I think going forward, are like figure out some of these discussions on the near-term milestones, make sure they're concluded, and then to start to socialize new work that has overlaps with other working groups or has been raised on the list. So here is our agenda for today. Just as a point about the packed agenda means you often get like a slot that's almost too short to to present in. So I think if folks who are submitting drafts, it's really useful not to have had the discussion on the list, such that we don't have to use the time slot to go through existing material. And then there's a couple of things that we couldn't find time for on the agenda. There's these two drafts in particular. There's an SR MPLS multicast framework draft that's going to be presented in PIM. And then there's a update for the BGP signaled SR policy for both the Yang and the Yang model that are going to be an IDR. Yes, Jeff. Okay, so it was Jeff Tanser and said that the multicast draft is also being presented in RTGWG. Right? John, get status. Okay.
So in terms of progress of document, we have the architecture document, which is in RFC editor state, and most specifically OS 48. So we have all authors fine, so we're waiting for the final go from the AD. For LTP interop, it's currently in ISG evaluation. There was one blocking comment. It is being resolved. So hopefully the new draft should be published this week. In terms of MSDC, it's also in ISG evaluation. There are comments, a blocking comment regarding the interaction between network and TCP. So we would like the authors to react faster, but as of today, I think the ball is in the ISG. Regarding the MPLS working document, so it's on the working group last call. We had a number of comments, so thank you for all the people who made comments. We're waiting for the authors to reply to all the comments. So there is at least one comment which is not addressed and possibly more. And also we're waiting for two contributors to reply to IPR. And finally, we have a new working group document, which is a Spring segment routing policy, which has been adopted.
You have a spring duck, awesome.
So that's all. First on the agenda is the Young, I believe. Yeah.
Hello, everyone. My name is Ying Zhen. I'm here to present an update of the segment routing Yang model. So it has been, I think, almost 2 years since we did a update of this model. And feature-wise, this model is very stable, has been very stable, and we didn't make many changes. So this one shows the overall tree architecture of this model, just to refresh everybody's memory if you are interested. So what's defined mainly in this model, we have the segment routing global block, the sRGB. So we support global configuration. This one, I want to stress, this one is the base model for segment routing. We do have the protocol-dependent model, the OSPF segment routing, and ISS segment routing that defines the protocol part in those two separate models. So this one defines all the protocol-independent parameters, sRGB, and we have the per protocol sRGB configuration. That's that as a feature. So if you support, you have a very specific, just say you have ISS user specific block, you can do that. Same for this one, we have the local block configuration. That's the local seed you can use. We have the maximum seed depth, MISD definition. So we support node configuration of MISD, also link configuration. So link, we have a list of interface that if you have configuration on link MISD, otherwise you use the node MISD. We also have some notifications that's supported in this model. So one thing to notice is we have the transport type defined in this model from the very beginning, because we have this model mainly defines the MPLS data plane. So we have the IPv6 transport defined in this one as an identity. I know the SRv6 model is defined in a separate draft. So I think we either use this one as the base one, as the base model. So SRv6 model can augment this model, or we can totally separate them. So that's, I guess, up to the working group's consensus. So considering this model feature-wise is already complete and it has been stable, we'd like to, if you have some comments, this is the opportunity to say it. And then we'd like to start the Young Doctor review. And after, because all the segment routing MPLS related draft are either in the final stage or in pretty much close to last call. So, and then we will last call this data model. So that's it. Any questions or comments?
Okay, so please have a look and read. We'll start the last call soon, and eventually we'll ask for a Young Doctor review before.
Yeah, we need the Young Doctor review first.
Okay. We'll do that.
Hi, Dhanendra Cisco. So for the common data types for segment routing, do you put it in this one, or do you have in common routing Young model?
So this, if you look at the draft, it actually consists two modules. One is defined in just the basic types, so other modules you can import, and then the other is just the specific, the segment routing configuration part, because the PCE, PCF, those protocols also use the basic part. So if you have any, if you look at something, you have different requirement, let us know.
Yeah, sure. Yeah, that's what I was asking. Thank you.
Yeah, sure.
Justin, short comment. So there's a number of SR Young models that don't reference this work, and this is just incorrect. The initial idea was to have the base types here and then reference them from other drafts, and you see number of models increasing, and there's no really coherence between them. Please take a look and reference to have proper structure in place.
Yeah, if you have, if you are defining a data model in routing area, we have the routing type first. Now, that's already an RFC that defines a lot of basic types like a router ID, etc., that you can reference. And this one also has a separate module for basic configure the groupings, so you can use for segment routing configuration. So if you are defining anything or augmenting anything in segment routing, you can reference this model. Thank you.
Ketan?
Hi, Ketan Taraudikar from Cisco, and giving an update on the SR policy drafts. We'll start with the segment routing policy, which was adopted by the working group. So the key update was the adoption call was started after the last IETF, and post the call, the version 5 of the document was adopted. There were several comments and inputs received during the IETF and also during the working group adoption call. The major change was that this document was reorganized, and the focus was to progress the core SR policy framework, and other topics were moved to separate documents, and we'll look at what those things. Besides this, there are also minor changes to clarify some detail, correct, and improve the text based on the comments and feedback. So this is an overview of how the original document has been reorganized. So we have the draft IETF segment routing policy. This remains and covers the core SR policy architecture. There is this draft SR policy consideration, which now has text mainly from the appendix section, and plus a few other text from the 05 version. What this covers is really some of the implementation and deployment aspects related to SR policy. We'll talk about it in the next presentation. And the third part, which was all the traffic counters, SR counters related content, which was section 13 in the 05 version, that's been put in this other draft, which would also be covered later today. So this draft, the SR policy architecture draft, now focuses on really these aspects. So there is the SR policy framework and how the information model, how it is structured, basically the candidate path, segment list, and all of that. It also defines the segment routing database, or what all information could be there in the segment routing database and used for SR policy. There is a list of segment types that can be used in the SR policy. This is the currently defined segment types. It also talks about validation of candidate paths and selection, tie breaking to select the best or the active candidate path. The binding SID concept and its usage, and there are different modes in which it can be used. They're also discussed and covered in this document. The other key piece is that the steering mechanisms into an SR policy, there are 3 or 4 different ways in which this could be done, and all of that are covered in this. So those sections remain in this document. There was some text related to protection and TILFA that has been improved, and some more concepts added there just to cover the architecture. So this is fairly mature draft, because been a lot of comments and inputs from the working group, multiple vendors and operators as well. So and this is being updated based on clarifications from both implementation and deployment and trial experiences. Since this is the architecture, there is the other aspects of it, like signaling, for example, BGP SRT, there is the Yang model coming up with it, OAM. So all of those are being progressed or worked on in different documents. So this document really focuses on the core SR policy framework now. So this is just an update. Would welcome review and more inputs and comments from the working group. Any questions?
Hi, I'm Andrew Stone from Nokia. The latest draft references about using PC initiated to deploy the SRT policy, but I haven't seen any drafts or extensions for PSEP to do this. So is there any talking about how we're going to map an SRT policy with color and multiple candidate SID lists to the PSEP messaging?
Yes, I believe there is some work going on that, but you're right, it's not yet been posted, but it's expected to be posted soon. Right now, the coverage, I think it's covered in the BGP SRT context, but the PSEP part is yet to be added. Right. I think, yeah, maybe Dhruv has a better update.
Dhruv from Huawei. So we have one document which talks about how do we associate various SR paths into an SR policy. So we have the document published. It's in the PC working group, and I will give a very brief introduction in the PSEP association, like the group of drafts that we have, which talks about PSEP association object. So that's one of the things. I can send you the link now as well. Thank you.
Thanks.
Hi, Harish, Juniper. So the O1 version of the draft has a text relating to symbolic names that can be associated with the policy. Would the appropriate BGP draft also be extended to send those names? Or
Yes, it's been extended. The latest version of the BGP has been extended.
Okay.
So it's a symbolic name for the candidate path. Yes.
So it also has a text in there that says, the name must not be used for mapping on the local device. That's probably something that local device can.
Yes. So the thing, I think the point there is that the name is not a unique identifier because the identifiers are different. But sure, I mean, implementation can use it.
Okay. Because there was a text like
It's just that the information model, the index, the name cannot be a unique identifier. That's what it.
Okay. Since it said must not, I thought local device could not actually map based on the name. Should it wanted to play services, for example, based on. So you're saying the name is not unique.
Name need not be unique.
Even on the single device, the name need.
It need not be unique because the way it's signaled, let's say from via PSEP or BGP SRT, that name is really not a key. So it is possible that its name is an attribute in those signaling, and that's the reason why this clarification.
Thank you for improving all the documents, Kate. And I'm Sue Harris, Huawei. For you and Drew, are you going to harmonize the BGP stuff with the PSEP stuff? I can take it offline, but we need to sort of cycle on that. Thank you.
Hi. So this is the SR policy considerations, which covers the text which was previously there in the appendix section. So the draft IETF Spring Segment Routing 00 version was posted identical to the 05, which was adopted by the working group. So this is really the appendix section 14 from that document. This is an informational draft, the contents here. And there have been minor changes to clarify and improve the text based on the feedback and comments. So what's really covered in this document is there is a SR Policy Headend Reference Architecture. This identifies really various components and their interactions. So we have this SR policy module, which learns SR policy candidate paths from various signaling protocols. We have BGP SRT, we have PSEP, local configuration, all of these. And then there is the SR policy database that is built up from signaling protocols like IGP, BGP, LS. So the interworking or information flow or what parts of functionality is implemented or may be implemented in one area component or the other is what's really clarified or covered in this document. It describes the SR policy dynamic path computation. This is really highlighting some key aspects of the computation so that we leverage the segment routing concepts like, taking care of ensuring maximum ECMP, taking care of SID lists or SID constraints in the computation. And there are various optimization objectives and constraints that are talked about. This is again mainly informational things there. Then the SR policy architecture draft talks about the candidate path and tiebreaker rules, but this document really has the examples which indicate how a headend would choose based on different paths with different attributes coming from different protocol sources. So those examples are covered here so that it's a better reference for implementation. The document also talks about the distributed and centralized control plane and the use cases which need centralized computation, some use cases which can be done entirely in a distributed manner, and others where a mix of both can be used. There are certain aspects of binding SIDs and use cases which are also described here. How binding SIDs could be discovered, how binding SID from SRLB can be used for SR policies where you need some sort of a persistency or like a well-known binding SID. And then there are a few other use cases that are covered, like for example, there is Flex Algo. There is some information about how optical or any general layer 2 interface could be modeled as a segment. All right. It points to other documents like there is a draft Anand Spring SR POI SR, which really talks about the SR policy in optical domain. So that's covered in detail, covered in the separate document, but this has a reference to that. The objective of this draft was to really document the implementation aspects and our experience and have some reference framework which can be used when describing the functionality in, for example, in a BGP SRT document. So like what part of the functionality belongs to, let's say, the BGP protocol, and what part of it should be done in a SR policy module that we talk about. And then there are really the deployment aspects and use cases, which is also covered here. So the content is already familiar because all of it was part of the original 05 version of the draft, which was adopted by the working group. It's fairly mature in the sense that it's been stable for some time, but based on updates and comments, feedback, it's being updated. So at this point, we would like to request for working group adoption for this draft. Hopefully, since it's already, the contents have been already through the previous last call, it should be easy or smooth, hopefully. And expect good review, comments, updates. Please share with us. Any questions or comments?
So I have some comments. I think there's a few challenges with getting this draft adopted, particularly because if you look at a bunch of it, it's kind of local to node implementation detail. So, how you should split functionality across different software modules, not all of which exist in all implementations, is kind of an interesting question as to whether we should include that in a draft in the working group. The other set of considerations, you'll recall when we did the policy draft adoption, there was some discussion with T's about what constitutes traffic engineering and what constitutes traffic steering. And so there was a deliberate split there, right? To be able to try and have the SRT work as kind of exist as a steering mechanism and not the path computation part. Given that this document talks a bunch about path computation, I think it needs to have some collaboration with T's. So we need to discuss exactly how that fits together. So I think we probably need to go through those discussions before we can kick off an adoption call.
Okay, sure. So on the headend architecture, yeah, it's a reference. It does not exactly need to be done that way in implementation, but it's more of a conceptual. The example that I gave is, for example, like a SR policy is received on a node via BGP, then certain clarity or information about the what part constitutes the BGP processing and what's, let's say, the SR policy processing. That clarity thing would be useful from an implementation perspective.
I'm not saying that the content is not useful. I think it's just the way it's written right now. It's the block diagrams you've got are very specific to that. Whereas I think you could call out, look, this set of functionality that you have, there's this other set of functionality. Here's how they interact. Here's what BGP will do for you anyway. Here's what won't be done. I think there's some possible restructuring that would make it less implementation specific.
Yeah, I mean, definitely welcome all feedback and this thing. And on the computation, it doesn't really cover the algorithm as such. It's more clarifies the, let's say, the segment routing specific aspects of it. But sure.
Maybe. I would say that it's quite a gray area as to whether what it covers is even really SR specific. There are some SR specific things in there in terms of, this is how you might go from the set of paths. But if you start talking about here's how to compute a path that has misses link affinity, then the overlap with, well, we didn't ever write a similar doc for CSPF. For RSVPT, like, do we need a doc? I think we should have these discussions as to whether it's a useful thing to have or not. Is this next on the agenda, or is it Jim?
Jim.
Yeah, I've missed it.
Good afternoon, everyone. Jim Guichard from Huawei. I just wanted to do a very brief introduction to a draft that I put together with a bunch of co-authors that are shown on the front page here. The reason that we started to work on this, does this work?
It should do.
I'll just do it. So the basic intentions of this draft were, I felt there was a lot of confusion between the work that we've been doing in the SFC working group for service chaining and some proposals that have been put forward for segment routing to do service chaining. And I heard a lot of talk about, well, they're competing technologies, but the reality is they're really not. They're complementary. So what I wanted to do was basically describe two application scenarios that show how the network service header that we've been developing in the SFC working group can actually work together with segment routing. And basically what we wanted to do was maintain the original intent of the SFC architecture, which was to separate the service plane from the transport. So there's two scenarios described in the draft. The first one is where the NSH encapsulation just basically uses segment routing as a transport. So if you're not familiar with what we've done in SFC, the encapsulation was built specifically so that it could work with any transport. So we didn't care whether it was VXLAN or GRE or MPLS or any of the different transports. We wanted it to be independent of that. And this scenario maintains that by allowing NSH to be carried underneath segment routing, whether it be SR MPLS or SRv6. The second scenario shows how you could actually integrate the two things. So segment routing, we build a segment list with services as part of the segment list, and then NSH is simply used as a mechanism to identify which segment stack should be pushed back onto the packet when it comes back from the services. So this allows us to remove all of the VLANs and other types of mechanisms that you would need between the forwarder and the service function, and just use the NSH as a way to identify which context we're in, and therefore push on the right segment stack. Next slide, please. So this is just a very quick picture. We described this in the draft. It just shows SR being used as a transport tunnel between two data centers where I'm using SFC encapsulation in the data centers, and then I want to do some kind of traffic engineering between, and therefore I can just push SR on top of NSH. Next slide. What we've tried to do with each application scenario in the draft is show the stated benefits. I'm not going to read through all of these. You can read them for yourselves, and they're in the draft. But we've tried to give some advantages of using this mechanism. Next slide, please. This basically is a picture that shows the integration, which is the second application scenario. So as you can see, once again, the NSH is carried under the segment stack, but we use the NSH path identifier to push on the necessary segment routing stack when we come back from the services. Next slide, please. Again, stated benefits are in the draft. I'm not going to go through all of these. I've listed them here. Happy to take questions on any of them. Next slide. We also show the encapsulation details both for SR MPLS and SRv6. Didn't show up very well on this picture, but again, it's in the draft. Next slide, please. So in conclusion, basically, the NSH-based service chaining and segment routing are complementary technologies. That's the main point that I wanted to get across with this draft. Although we can do service chaining purely with segment routing, there are a lot of issues doing it with SR MPLS, mainly around metadata capabilities and so forth. But there are also arguably issues around doing it with SRv6 as well, which happy to have a conversation on those. I don't want to go into it, but it's fair to say that we could get SRv6 to do what NSH does eventually. But obviously I'm interested in getting things deployed with technology that we already have, and I don't want to reinvent the wheel all over again. It's taken us 5 years to get to where we are in SFC. I don't want to do it all over again. The NSH gives us the transport independence, and the SR gives us a really efficient way of steering the traffic through the intermediate nodes that without us having to carry the per flow state. So by combining these two technologies, hopefully we can get that transport independent SFC solution, and it's a solution that we think takes advantage of the merits of both technologies. So last slide, please. So next steps, obviously we want to request feedback from both the Spring and the SFC working groups. I did talk to Joel, my co-chair in SFC. We need to talk to the Spring working group chairs. We personally feel that it's appropriate, if the working group wants to do it, to adopt this work into the Spring working group. But again, that all depends on an adoption call from the working group and whether they want to pursue this. So any questions?
Thanks, Andrew Dolgan and Nokia. And if we go back to the conclusion for a second, I would like people to really read this sentence carefully. They are complementary, but if we look why we did NSH long time ago, was to actually isolate it from transport. And yes, you can do this with segment routing. You can embed the NSH kind of information in segment routing, but that defies the purpose why we separated services from transport. And all the stuff we've been doing over the last 3-4 years as an industry was to provide a way to actually consume networks. And the more you put service knowledge into the transport, the more barriers you create. So I would strongly ask people not to think twice before pushing for this kind of embedding of services into user data plane. So I agree that with a lot of conclusions.
Okay. Any other questions? Nope, crystal clear. Thank you.
So I'm going to present an update on the SR service training, where we completely integrate the service as part of segment routing. And the first thing that we changed since the last presentation at IETF 101 was that we renamed the draft into service programming with segment routing. And the reason is that segment routing enables to do more than just sequencing or chaining services. You can actually program them. You can, using a service 6, for example, and seed arguments, you can pass additional information to each service. But you can also leverage the information in the SRH and the segment list, as well as other information, in order to do some advanced programming stuff like looping, branching, and so on. So the major change in the document is that we updated the section 4 and 5 to leverage the segment routing policy architecture that has just become a working group document. This resulted in an overall simplification of the proposal. So we updated all the terminology. And the reason why we did that is that before we were using some terminology from RFC 7665. But our proposal is really independent from this RFC. Here, the services are integrated within the segment list, within the segment routing policy. And, well, we are not trying to apply or to implement the architecture from RFC 7665. So a reminder on the SR policy framework. The idea is that you have a headend that steers traffic into an SR policy that can be done using a local policy like static route on the node, or automated steering using BGP, remote steering. But all of that is described in the SR policy draft. And that SR policy contains segments for VPN, it contains segments for traffic engineering, but it can also contain service segments. And we believe that for some use case, it is useful to have these service segments integrated directly into the SR policy, and to use a single protocol for the service part and for the traffic engineering or VPN part. It is also completely stateless in the fabric. All the state, as any segment routing proposal, is located at the headend. Then we did some other changes. One of them is for the segment routing aware services, since we're starting to get some services with segment routing native support. We added those in the draft. And also, as I was mentioning at the beginning of the presentation, a few notes on the advanced network programming capabilities that segment routing provides. We also added the metadata carrier, the TLD definition into the draft, and did some various editorial fixes and changes. So the next step for this draft, well, we would like to look at the service failure detection and recovery mechanisms, and also load balancing over multiple instances of the same service. We have some solutions for that. For example, using multiple seed lists. As you know, a segment routing policy is associated with candidate path, and each candidate path can have multiple seed lists, and you do load balancing between these seed lists. But we we would like to do something more for the service segments. And also, we are still looking for working group input and feedback on this proposal. And we would also like to ask for working group adoption. I think that was already done on the mailing list a couple of months ago. That was before the recharter, so things have changed. And we would like to ask again. Well, that's all for this presentation. If you have any question, please feel free to come.
One question regarding metadata.
Yeah.
There has been some change in the SRv6 document, which is currently in last call.
Yeah.
My understanding is that the TLV has been removed. Is it correct?
No, there are still TLVs.
No, the TLVs are there, but the NSH TLV or the metadata TLV has been removed. Currently in the draft, the spring draft, it's not clear whether the document reference existing ways to add that metadata, or if the goal is to define a new extension to carry metadata.
Well, we are defining a TLV in that draft for carrying metadata. There are other drafts defining other TLVs, for example, for OEM, for the segment routing header. Then, I don't know, maybe we will add more TLVs into this draft or in other drafts. I don't know exactly how to answer the question.
The question is related to whether you want to change the data plane for IPv6 on MPLS. Is it referencing existing document, or do you plan to specify a new extension to carry metadata in that document? So, for example, you say metadata could be carried in which one? In the tag.
Yep.
Which already exists.
Yes.
So nothing new. You said it could be carried in NSH carrier TLV, which was the case maybe 2 months ago, but currently it is removed from the SH. So that means that draft.
Why we have it in that draft, and obviously that section will need to be reviewed with the 6-man working group.
So your intention is to define the TLV in that draft?
Currently, yes.
Yeah, and for the MPLS data plane?
For the MPLS data plane, that's open for discussion, I would say.
Okay.
So I appreciate your stating explicitly you were ignoring RFC 7665, but the whole point was to avoid a massive interoperability problem where, let's say, we have we have SFC over segment routing v6. We have SFC over MPLS. We have SFC over Ethernet. We have SFC over rate IP. We don't want an N squared problem. NSH gives us an order N problem. You have to map to a transport. Understood, we got to map to transports. We're not reinventing those. What you've done is create not just a transport, but a complete representation, which means we're into a full mapping between every representation if we follow this pattern. Segment routing for v6 isn't so special that we should create a new pattern for how we think about interoperability just for that. Seems like you're leading us down a path that makes our tasks a lot harder. Why?
Well, one reason is that with NSH you need a lot of state in the network, as you know, and
a lot of state. No, you need some state, but a lot is not very prejudicial.
Intermediate points in the network. While with segment routing, you have all the state at the head end, and we believe that for some use case, it can be better to keep all the state at the head end and remove it from the network.
Every problem we run into, yes, there are trade-offs, but we try not to design new protocols for every special corner case. It hurts when we do that.
So it's Jim again. I had a comment on the TLVs,
Yep.
and it's another why comment, and that is, why do we have to go and redefine a whole bunch of TLVs that we've already done? It's almost like, and it's frustrating because it's almost like we're trying to make segment routing into the hammer. It can fix everything. It can do everything. And damn it, if it's not with a segment routing hammer, we're not doing it.
Well,
And we want to, we have to reinvent everything. And that's what's frustrating. It's like, let's use technology that we've already developed. Let's not try and make it has to be the segment routing hammer. I mean, it's frustrating. So you mentioned you removed the NSH carrier TLV.
no, the NSH carrier TLV is still there.
It's gone. Last time I read the draft, it was gone. I don't know if you moved it somewhere else.
Yeah,
But
it went from the 6-month draft, the SRH draft, to that draft. That I'm
okay,
referring
so it's
to.
moved to another. Okay.
Yeah, it just moved. It's still there.
Okay. I guess I want to encourage you to look, we've already done a lot of work on the TLVs, and we're still doing work on the TLVs in the SFC. So let's collaborate on that, and let's
Yeah,
not
sure.
reinvent it. That's my point.
Yep.
Yeah.
Thanks.
This is Zafar. So if you go with the approach that we are afraid to touch anything new, then we would not do ever anything. Okay. So here we have case where you have multiple layers of doing things, and each layer is doing over and over the same thing, like say with the states in the network. So what is being told here is that for SRv6, you can do not only service chaining, but you can do service programming through the states. It removes layers in the network, and we don't have to deal with the multiple layer or maybe this all problem that we're talking about. So what is wrong with that? I mean, what is wrong in improving on something? I don't understand.
Hey, Andrew Dolgan, Nokia. Hey, as a vendor, I love SRv6. It will double my traffic, so I love it. I'm not sure if anybody will pay for it, but yeah, let's. It's seriously, it's craziness. Please don't make statements. You need more state. You need more state in the network. If you need more state in the network, you're doing the wrong things in the wrong places. Again, network is there to forward. NSH is there to do services. If you do it properly, then that's simply not true what you said. And again, just because we can do something simpler for a particular simpler use case, just because we can, it does not mean we should. Because then we're going to have a simpler case here, and somebody at the end will come to me and say, please implement this, please implement this, please implement this. And from 3 simpler cases, I have a hell to support. And 5 years later, you need a PhD to manage a network, or no operator is willing to touch anything because it's so complex that you need a PhD to introduce any technology. So there are reasons why we have different protocols for different things, and segment routing is not. It's not a panacea for everything. I love the technology, by the way, but not in here.
I'm going to cut the line because we're already over for this slide.
One question on Java. So Greg asked how you envision separation of transport OAM and service OAM on this proposed architecture. The OAM on the transport versus
OAM?
Yeah.
Wait, can you restate the word?
Yeah. How do you envision separation of transport OAM and service OAM on this new proposed architecture?
I believe in that case, well,
Take it to the list, please.
the transport OAM would be used to check the services again. Sorry, you would use the same solutions to check the transport and the services. But there is another draft on segment routing OAM, and It should. I'm not sure about that. I will check.
Pablo?
Yes. Good afternoon. This is Pablo Camarillo from Cisco. Today I'm here to talk about Draft Illustrated SRv6 Network Programming Revision 5. So as you might already know, SRv6 network programming is in a sense the capability of create a distributed program in the network as a set of individual functions through an SRv6 domain. Now this document, what it is doing is describing the concept itself and some of the most basic functions that are used across a set of shared use cases. So if we look at the content of the draft itself, what we are defining is a new set of SRv6 functions. So these are the ones listed on the left-hand side, where in essence you have some from the most basic function, which is the endpoint, or the endpoint with layer 3 cross-connect, to more functions like the decapsulation with IPv6 cross-connect, so the DX6 or DX4, endpoint with decapsulation in IPv6 or IPv4 table lookup, and so on. Then we are also defining a set of transit behaviors, transit with insertion, transit with encapsulation, transit with reduced encapsulation, and transit with layer 2 encaps. Then the draft is also defining a set of basic intra-domain basic security ACLs, as the inter-domain would be part of a separate draft. And we are also defining a set of basic counters for these SRv6 behaviors. The draft is also giving a set of use cases. These use cases are all of them leveraging the functions that I explained in the previous slide. These use cases cover basic security, layer 3 VPN, layer 2 VPN, SRTE for underlay SLA or with either at an ingress fee or a midpoint, end-to-end SRTE policy, TLFA, or SRTE for service programming. Notice that the draft is not describing fully how we create each one of these use cases. So for example, if I go into TLFA, what this draft is describing is how to leverage the functions that we create, that we have defined in this draft to do TLFA. But of course, the TLFA mechanisms are described in a separate draft. So if we look at the ID history, we published this draft in March 2017, where we presented it. We presented, we included the main draft, some of the most basic functions and illustrations. This was presented in IETF 98 in Chicago in March last year. In June 2017, we published a revision 1 that was just a minor update with some draft clarifications. We also included a formal definition of the counters, which before were described in an abstract manner, and now they are defined as a counter 1, counter 2, counter 3, so they are concrete. In October 2017, we published the revision 2, which is including the EVPN functions, so NDX2B, DT2U, and DT2M, and the related illustrations. We also added a new function, so the endpoint with decapsulation and IPv4, IPv6 table lookup. And also, we moved the service programming related functions into the draft subclad draft. We did this with the objective to leave this draft with only the basic functions that are required in the most common use cases. In December 2017, we published the revision 3, where we added the OAM. So we describe how the SRHO bit processing is done, the end.OTP and function and the related illustrations. In March 2019, we added support for the reduced SRH following the 6-month SRH draft. So this involves the functions tinsert read, tencaps read, tencaps to read, and the NV6. And we also added the IANA registry for the SRv6 endpoint tabs, with the objective that all the control plane drafts can leverage the IANA allocated code points to signal the support for each one of the functions. Right before this IETF, we published the revision 5. It's just containing some text clarifications. It's including the NV6 reduce function that, due to an editorial error, was not added in revision 4. And we also moved away the OAM content, so the OBIT processing and the end.OTP function, into the OAM, the SRv6 OAM draft. If we look at the technology state for this draft, we, as you might already know, we have large community support. We have multiple interoperable implementations, both open source and proprietary. On SIGCOMM 2017, there was an interop where there were 2 different vendors and several different open source implementations. On the ENTC interop report this year, there was also one vendor that had already shown interop and another different vendor. And all this information, we wrote a new draft to put all this information into draft is Spring SRv6 interop. Specifically, it's quite important for the open source implementation. So in Linux kernel, Linux SRX module, and FDI BBP. Now, some of the related work that is based on this ID is, for example, draft Dukes Spring SR4SD1, draft IETF DMM SRv6 mobile user plane. Notice that the DMM draft is defining new SRv6 functions, which are specific to mobility, but since they are specific to mobility, these functions are defined in this ID. Another draft is the draft subclass, which was previously presented, and then we have the SRv6 VPN, SRv6 OAM, which is also defining new functions, SRv6 Yang, Lisp SRv6, BGPLS SRv6 ISIS, and NoSPF SRv6. So what I would like here is to gather working group input and feedback on this work. So please.
Ron Bonica, Juniper Networks. Several of the SIDs that you define in this document take information that is currently encoded in MPLS VPN labels and moves it into a SID. I'd like to see you address 2 things in the document. First, why is that necessary? Why is it not okay where it is today? Second, why is it a good idea to move it into the IP destination address along with routable information? Why not move it into some place where it's separate from the destination address as it is today?
So, so your question is, why don't we keep separate the VPN segment from the rest?
Well, 2 questions. First, why is it necessary to re-encode it? The L3 VPN service works today without re-encoding the VPN label. Why is it necessary to change it? Second, given that it is necessary to change it, why move the VPN context information from a separate field where it lives today in with the SID or the IP destination address where you're proposing to move it to? 2 questions to be answered in the draft.
Okay, thank you. So,
Hey, Darren Dukes from Cisco, if I can just help out here. So I think the question is, if I can paraphrase you, why move something that's currently has an MPLS label into an SRv6 SID for an SRv6 data
First,
plane?
why move it?
Yeah.
Second, if you're moving it, why move it into the same field that other information lives in today?
Yeah, okay. I guess the simple answer is this is an SRv6 data plane versus an IPv6 data plane versus an MPLS data plane. And the second question, I think we should probably answer in text.
So your presentation caused me to go look again at the draft and then think about something I saw which made perfect sense in the segment routing header draft, and I'm now confused. So I hope I can provide a clear question. This is about the transit SIDs, which are in the draft and are on your table of SID programming SIDs. The text says you're at a node N, you have a destination address of B, which is not a local SID. But you're going to do some sort of SID processing that is somehow related to something, and I'm not sure what from the text, being a transit SID. Well, the base segment routing draft says explicitly, and for obvious reasons, for consistency with 8200 and good practice, if it's not one of your SIDs, you don't need to do anything with it. So I don't understand how these transit SIDs work.
So, so in essence, what you are putting into the destination address is going to be a SID that is going to be processed at another router.
Right.
So you are not going to process it.
Then why are you doing anything? It says
I'm
that,
just putting it into the segment routing header.
No, it says node N receives a message with a destination address that is somebody else's SID.
No, draft is not saying that. draft that is sent is node n for the pseudocode for all the functions. It's draft n receives a packet that is that has a destination address S, which is a local segment to node n. That is what the draft
That's
is.
not what it says. Go read your text again. It's very explicitly says is not a local SID. In fact, it doesn't ever tell me it's actually a transit SID.
I'm sorry, I apologize, but I completely disagree with you. I believe that the draft in the text is clear. I will reread the draft again, and I will get back to you on the mailing list because I.
Please, the mailing list is fine.
Okay.
Hi, my name is Uma. Can you go back to one slide, please?
This one?
Yeah. So the second draft IETF DMM SRv6 mobile user prints great work. So I have only one comment on the draft because you put it here because it's connected to the programming I'm commenting here. SRv6 can be used as an underlay for the transport backhaul transport networks. Great, if it works. But the only problem there is in the name of removing GTP tunnel, the TEID is encoded into IPv6 address. What happens with this is complete all 5G mobility scenarios dependent on the IPv6 underlay. There's huge networks underlays built on MPLS today. This separation will help actually, so that underlays can be independently deployed, MPLS, IPv4, IPv6, SRv6, anything. Except that part, it is good. You might have to reconsider that actually. So the TEID need not be encoded into IPv6, SRv6 address.
Okay.
I can follow up. Certainly, for source one. The concept of the second draft, IETF DMM SRv6 program you plan is introduce the GTP alternative. It's not totally core of the GTP user plane. So the idea of the SRv6 mobile user plane is integrate both underlay and user plane layer.
So the programming part in the underlay is fine, but the GTP separation, GTP keeping as overlay is better. If you underlay overlap collapse, there will not be any underlays you can put together actually. All MPLS has to be upgraded to SRv6.
The separating underlay MPLS layer and user plane is not a good at to integrate the both transport and mobile user plane operation. Integrating both of two is integrate both of two operation. That's the
what happens
I would
is
suggest
you're,
that
you're
this,
forcing everything to be SRv6.
Yuma, could you send your comment on the list and we can discuss on the list? Thank you. Okay, next is Chris, I believe. Chris, do you hear us?
Yes, I'm here.
Okay.
Can you hear me? Okay, excellent. If the camera can get moved towards the crowd, that would be good because I'm not going to be broadcasting any video, so it'd be good to see who's asking questions.
Chris, is there a way for you to speak louder because we don't hear that well?
Let's see. I can
Okay.
just kind of talk loud like this. Does that work?
Whatever you can.
Let me see. Okay, well, I'll talk as loud as I can. Will this work?
Yes.
Okay, great. So this draft is talking about how to provide node protection for traffic engineered SR paths. I'm going to first start out with a link protection example and kind of walk through this rather complicated topology, but this issue is actually sort of a matter of details and getting all the details right. So I think it's worthwhile to actually go into the detailed topology examples. So the topology design on the left there, I use a notation where all of the node SIDs, all the node SID indexes can be derived from the node number, as can the sRGBs. So, you know, these nodes have numbers, 2-digit numbers. So the 2-digit XY value will be the node SID index. We're still on the first slide there. yeah, wanted to stay there. Thanks. And the sRGBs are one followed by the sRGB, excuse me, by the index value or the node number, followed by 3 zeros. So for example, node 83 has the index 83 and sRGB of 183,000. Similarly, the adjacency SIDs for a given link between node AB and node XY can be derived from, it'll be 700,000, and the digits AB, is the slide still showing? Okay, there we go.
Yeah, so we're just trying to fix a presentation issue in the room.
Okay. Do you want me to wait or continue?
No, I think that it's still on one screen, so it's fine.
Okay. Yeah, probably it's intending to save the other screen to show my video, but I'm not streaming anything, so that probably won't be fixable. Okay, so with this scenario, in this example, we're going to have node 70 sending a packet out its interface 70 to node 1 with the label stack, that particular label stack shown. I won't read out the whole label stack, but it corresponds to the node SID for 2, a node SID for 80, another node SID for 83, and a node SID for 90. So that's going to steer the traffic from 70 to 1 to 2 to 3 to 80 to 83 to 90. And I've kind of used this notation where the light blue nodes and arrows correspond to, the arrows are adjacency SIDs, the blue ones are adjacency SIDs, and the blue node numbers are actual node SIDs, so that you can tell sort of where the anchor points are of this SRTE path. So in this particular example, just doing looking at the failure of link 1 to 2 without node protection, this is just the link protection case. We have a normal forwarding entry for the incoming label of 100,000, so 101002. You're going to pop the label and send it out the interface from 1 to 2. For the link protecting backup path, you're going to pop the label and send it out the interface 1 to 21 with this different label stack. And that label stack describes in this case, the TILFA backup path, going out to 21, 22, 23, 2, and then it 3 and 30. And it basically merges the backup path at node 2. Now this is okay when you just have link protection, when you don't want to apply the condition that you can't go through a potentially failed node. But so in the next example, we'll show, so go to the next slide. So in the next slide, that isn't the case. First, we can't go through 2 in the backup path, and we also can't, we have to basically go farther in the path to the next, basically the next node where labels have significance. So the next segment in the path. So again, in this example, 70 is sending out the same label stack, which results in the same instantiated path. But for node protection, and we still have the same, primary next hop label forwarding entry, but the backup path can only be determined by looking at the first 2 labels, both the top label and the second label in the label stack. So in this case, we're going to, in the backup path, send the traffic out interface 1 to 21, but we're going to pop those 2 incoming labels and push the label stack shown below. So that's going to, and that results in that larger label stack as you're leaving node 1 to go to 21, which results in this end-to-end path immediately after the failure that goes 71, 21, 22, 23, 24, 3, 80, 83, 90. So going on to the next slide, this idea of looking at having to look at the top two labels is kind of special for this case. We don't have to do it for link protection, but I want to sort of motivate, why do we have to look at the second label for node protection? And here's an example of you have one path, path A, which is the one we described before, and depending on the value of the second label, for path A, we're trying to get, it has a node SID for 2 and then a node SID for 80. We are going to have to interpret the label after the node SID for 2 in the context of the following node, or the next segment in the label stack. So in this case, we end up using the label value of 124080 in that case, which is basically the node SID for 80 at node 24. I would also point out that this notation of using sRGB values, using a different sRGB value for every node is not necessarily something you'd want to do in a real network. You'd probably want to use the same sRGB value. But if we're going to have a general solution for this problem, we, in general, should take into account the possibility of different sRGBs. So I've explicitly put in every node having a different sRGB just to both highlight that point so that we don't sort of oversimplify the problem and come up with we could explicitly decide that we don't want to cover that case, but at least in general, I think we should be covering that case. So the other path possibility here is path B, which goes out 70, 1, 2, 3, but then takes a right turn to go to 34 and then gets released up through 83 and ends up on 90. This path is going to have a different second label, and in order for the PLR, node 1, to be able to produce the correct label stack for this, it's going to have to look at the second label as well. Any questions here? Okay. So moving on to the next example. So this is just illustrating why you really also need to look at the first label so that you can understand the second label in the context of the first label. So just kind of cooked up a topology here where we added node 4 into these into this topology, and path A and B in this case correspond to a path that either goes through node 2 or node 4, but are otherwise identical. And you can see that in order to, you need to look at the first two labels. The first label in order to understand the meaning of the second label, because you're basically looking at the second label in the context of the first label. So moving on to the next two slides, just illustrate that you can, the same thing applies if you have adjacency SIDs in the traffic engineered path. The same kind of solution applies.
Chris, you're out of time. If we can move to the conclusion.
Yep, go to the last slide. Final slide, yeah. So So we'd like the chairs to consider conducting a poll for working group adoption. One issue that has been, it's been brought to our attention that the TILFA draft also has some text that describes a solution to the same problem. It uses the solution description uses a second lookup based on a sort of a modified second label. The description actually in our draft uses context labels. The description that is in this presentation actually is kind of implementation neutral, I think. It just talks about, looking at incoming labels and then outgoing labels and not your mechanism for figuring out what those labels are. So there's room, I think, for discussing both of those solutions in a draft. But I think this falls on the side of, practical implementation issues that it would be good for the working group to have a draft on. We're proposing an informational draft.
One question, both drafts are in two different working groups. Do you see the discussion to happen in which working group?
I think it would make more sense for it to be in Spring, mainly because the solution, the actual backup path we've described happen to be TILFA backup paths, but they could be any form of backup paths. They don't necessarily have to follow the post-convergence path. They just need to get back to the SRTE path so they can start using the rest of their labels properly.
Okay, thank you. Any comment? So we have
Stuart Bryan. I'm a bit confused here, as always. Do you have to dynamically work out what your repair path is with this technology, or is it computed ahead of the time like it is normally for fast reroute?
Yeah, it's all computed ahead of time.
So if it's computed ahead of time, then how is this consistent with the SR philosophy that the head end determines the path and the nodes in the middle know nothing about it?
Yeah, in order to provide node protection, you have to violate that to some extent. You have to look at, not just the first label, but the second label.
Stewart,
yes.
Do you think you can send the comment on the list, because we are a bit running out of time?
Okay, I will
Thank
send
you.
the comment
Thank
to
you
the
very
list.
much.
I'm just trying to understand how it works.
It will be easier to resolve, I think. Thank you. Next is Faisal. Thank you, Chris.
You're welcome. Thanks.
Hi. So I'm just presenting a new draft that we posted some time back for supporting MPLS ping over flexible algorithms. Okay, so RFC 8287 defined. Yeah, so FEC is defined, SR IGP FEC is defined as a prefix length, and then protocol. But now with flex algorithms, now same prefix can be advertised using multiple prefix sets. So this information alone is not sufficient. RFC 8287 at that time it wasn't there, so we need to extend 8287 to add that support. So I just use a sample topology as an example. So here we have the default algorithm is supported by all of every node, and then the green nodes support algo 128, and then the red one support algo 129 in addition to that. So if you go to the next one. So now, for example, if you do, let's say, MPLS trace route starting from node 0 for destination node 9. So if it goes to node 1, and we want to do it for algo 128. So in this case, the node will receive the prefix length, and the protocol. But that means that it will resolve the default protocol,
but the incoming packet has the label corresponding to algo 128. So it will falsely assume that there's a mismatch and indicate an error. And there could be other cases, for example, the packet ends up at a node which only supports default algorithm, but not the one that we wanted to test, and we may say success in that case when it actually is incorrect. So we should actually extend 8287 to add that support. And solution is really simple. We just have 16-bit reserved field, so we can use the 8 bits from that to carry the algorithm ID. By default, for all the algorithm unaware applications, they can use algo 0, so you don't really need to worry about the older implementations and all. And then whenever you want to ping for a particular flex algo or traceroute application for that case, so you carry the algo ID in the algo field. So next slide. Yeah, so in this case, if you see now, when the node is doing validation, it will, in addition to prefix, its length and protocol, we are also carrying the algo ID. So we can carry the corresponding prefix it, its next stop, and so on, and we can do the proper validation and return success or failure. So that is the draft very simply. It is a really simple draft. And if you go to the next one. Yeah, so we're really trying to address a gap that we think this draft will address. It maintains the backward compatibility. And then we're going to present it to MPLS and Spring Working Group. Right now, we're seeking the working group feedback from Spring Working Group. If you have any questions over here, I'm happy to answer, and you can also post it to the mailing list. All right, thank you.
Thank you. Next, Linda. You have 6 minutes.
Make it fast. So the two purposes for presenting this draft, one is to show that how the segment routing is useful to help the SD-WAN traffic. Second part is really about end-to-end path traversing through hybrid network, because the reality is we won't be able to have SR in day one. The traffic have to go through different part of the segment of not SRv6 enabled network. So let's get it started. So for SD-WAN, right, there's has been in the market for last 5 years. The classic SD-WAN is being like two endpoints which are interconnected by like provider network, MPLS, or SR, or lease line, and being supplemented by a third-party path, which can be public internet. So that's the classic SD-WAN. Looks really simple, but actually in deployment, there are lots of issues, mainly because of mesh interconnection among all the endpoints. That's why SD-WAN, even though has been in the market for many years and the deployment has been limited. However, as SD-WAN and more enterprises have been finding that the digital transformation require them to put the data into specific locations, whether being regulatory purpose or whether being closer to their client. So that require them to place their application into like cloud data center. And even with them being already interconnected by their own VPN or lease line services, there may be last mile, which is not, they don't have the physical infrastructure. So SD-WAN come up with a very convenient way to interconnect those workloads hosted in cloud data center. But the problem is, when we use SD-WAN, like here between E1 and E2, just simple SD-WAN will go through traverse internet. And for a very short distance, no problem, it's good convenient solution. But for when those two locations are far apart and the performance become unpredictable. So it is highly desirable and to put bigger part of a portion of the path into a provider domain. Then people will ask, then how does SR have anything to do with this desired deployment? Here I want to explain why segment routing is useful to enable this desired behavior. For one thing, for SD1 path between two endpoints, especially when they actually connected by like internet, for example, there could be multiple ingress nodes or multiple egress nodes to reach your preferred destination. And we have applications like attached to the endpoint. Here we have like, for example, E1, we have here for the simple illustration, we have A1, A2, A3, and A1 need to talk to Z1, but that traffic, because of the specific requirement by this application, they have to go through C6, for example. And A2 to Z2 application flow has to go through, for example, C4. So with that, if just traditional MQoS network, and you have to do lots of provisioning configuration to make those flows symmetrically traverse through specific edge node, whether ingress or egress. With segment routing, it becomes very simple. You can put a policy into the ingress node, and then the traffic will guarantee to traverse your desired egress. So we find this very useful. And just for emphasize on that, for the path between E1 and E2, the encryption, IPsec encryption is really end-to-end encryption. So intermediate nodes don't really terminate IPsec tunnel, or they don't have to do the peer-to-peer IPsec key, rekey, all those complicated protocol in there. So that's why we find SR as being very useful for that. And so maybe I just use this as an example. So for SR to be useful for this, there could be multiple approaches. One is the binding set can be actually encoded into the source node of the SD1 path. If they are, especially if they belong to the same administrative domain, and you can put a binding set into the E1 nodes. And another thing is we find out that for many of those services, it's almost impossible for the SR domain edge node to be able to differentiate traffic based on services, because services not just based on the SLA, there are many other requirement criteria. It's just very hard for the edge node to actually be able to differentiate their services. And most of services actually are marked by the E1 node and the edge node. So for the binding set to be exposed to E1, that is a very good solution, but the problem is if the E1 belongs to a different administrative domain and your binding sets cannot be exposed to those SD1 nodes, then we think we can use a simple kind of way to carry the information. Like, for example, if between E1 and C1 becomes like using GRE tunnel or VXLAN tunnel, and we can use the GRE key, or we can use the source, UDP source port to differentiate the application. And then the controller can inform the ingress node how to mapping those key into appropriate binding set. So just reiterate those 2 points. This just for illustration purpose. For example, if we use the GRE encapsulation between the SD1 endpoint to the ingress port, node of the PE, and we can use a GRE key to indicate, differentiate different kind of flow requirement, and then controller can inform the ingress node on how to do the proper mapping. But not all the legacy network equipment support GRE key, and you can also use the UDP source port to do the differentiation. There's being discussed on the mailing list because UDP port typically being used for the entropy purpose, and we utilize that to represent, differentiate different application. There may be an issue there for ECMP. But if the last mile is only a few hops away and not many actual paths between the SD-WAN endpoint to the PE, it's not a big issue. But anyway, we want more feedback on the mailing list using this UDP source port to do the differentiation. Another part is how to represent the security. The problem is once we have a provider network, the PE has the port facing the internet, then it bring up lots of security risks to the provider network. For one thing, we all know there could be DDoS attack to those PE once you have a port facing the internet. So that part requires some kind of anti-DDoS function to be enabled to prevent those unwanted traffic. Second part is you could have malicious users to spoof the CPE source address to be able to get the traffic traverse through your own provider network. And that one comes down to kind of trade-off, how much as a provider are willing to put into the edge to prevent those unwanted traffic versus letting some amount of traffic to traverse. And we are proposing that using some kind of a new protocol type to maybe using part of the GRE key to basically represent those are the legitimate traffic. For one thing, the actual payload between the two endpoints are encrypted. We're only talking about the traffic ingress into the PE and to prevent unwanted traffic.
Linda, you will need to conclude, please. Okay,
I'll finish quickly. Since we only have limited time, I will not cover this multi-domain case. For the SD-WAN, actually, there will be more issues. There's a tunnel between two endpoints, especially when they don't have secure channel between them. To manage the IPsec key negotiation is quite a lot of work. And there are lots of gaps, like using NHRP, DMVPN, there are some issues. So we're going to have another session to discuss the gaps of today's available protocols. That will be in RTG working group on Thursday. Hope people can come to join to discuss. Another one is for the IPsec auto configurations, because today it takes lots of manual configuration to do the IPsec configuration. And if you want to do a large-scale SD-WAN network, it's not scalable. So there's a working group draft in the I2NSF talking about auto-configure of those IPsec parameters. And I hope people who are interested are welcome to join the discussion. That's on Wednesday afternoon. Thank you very much.
Yes, John, and Darren, if you can prepare.
Short comment. So since in a lot of cases it's going to be management system to management system interaction, probably should also discuss it somewhere where management is involved.
Okay, thank you.
And there will be many time in RTG WG to discuss, I think, the SD-WAN subject. Yeah. So you're welcome to. No, Robin, we don't have time, sorry.
All right, guys,
But Robin, you can ask on the mailing list.
All right, I'll try to make this really fast. All right, this draft Duke Spring SR for SD-WAN actually used to be called Draft Duke's SR for SD-WAN 0. It was presented at IETF 100. It covered a lot of the edge SD-WAN edge to SD-WAN edge stuff that Linda's talk covered, as well as the selection of including the selection of an SR policy through the underlay. Linda's just so we can get this out of the way. Linda's draft has gone down the road of looking more into what happens when we have a separate CE to PE. There were sections in this one that have started to build on that, and Linda and I are going to be talking tomorrow to try to see where our commonalities are and bring things together, because that's probably a question or comment that'll come up at the mic today. right, so what we've added is a single provider example using n.bm or binding to a SRv6 binding to a MPLS policy. And we've added a single provider example using an SR MPLS over UDP for CE to PE connections where they are not directly connected, so where there's a transit provider between the CE and PE node. And we have that documented for SR MPLS use. Just a quick overview here. SR for SD-WAN really looks at the service level agreement and providing a service level agreement to an over-the-top VPN with scale and security. For the SD-WAN in particular, it allows selection of non-default paths through a provider's network for SD-WAN edge nodes, CE nodes. The SD-WAN edge nodes use a binding SID to achieve this. SRv6, it's an SRv6 binding SID for an IPv6 data plane. For IPv4 data plane, we specified the use of an MPLS binding SID over UDP. Of course, there's other methods you can use to select an SR policy through a provider's network, GRE or some other mechanism to specify a key that will allow you to select that policy. So the binding SIDs are per customer, per SLA, per endpoint instantiated at the PE closest to the CE. The question then is, how does a service provider provision that binding SID? And the answer to that is on demand from an SD-WAN controller. Who would request the binding SID from a provider, and we started the protocol to request that. And in subsequent drafts, we're going to be looking at how that protocol gets built out. There are subsequent versions of this draft. We're going to be looking at how that protocol gets built out to make that request between the SD-WAN controller and a service provider controller that manages SR policies. So service provider controller then provisions these SR policies to the closest PE node to the CE that they're requested for, and instantiates a binding SID at that SR policy, either an MPLS or SRv6 binding SID. And this is close to the end here. Currently we have SRv6 binding SIDs defined, and we have MPLS binding SIDs defined, utilizing RFC 7510 for MPLS and UDP encapsulation. We define directly connected CE to PE and not directly connected CE to PE cases. We'll be adding the not directly connected CE to PE with SRv6 in next revisions, as well as the SD-WAN controller to the service provider controller protocol and extensions, and exploring that area and seeing what needs to be done. So at this point, we're asking for collaboration. I know Linda will be collaborating. So if other folks want to join us, please drop us emails to the list or individually, and we can move this work forward. Yeah.
Hello, Darren. It's Daniel Way from Bell Canada. So the previous draft from Linda and this work that we've been looks very similar. So I guess maybe we're going to have to calibrate the two drafts together, isn't it?
Absolutely.
Good. Yes, I will.
Okay, any other questions, folks? We have another 30 seconds, or are we out of time? That's it. Oh. Okay, thanks.
Thank you, Darren. We're a bit late, so if you can skip maybe this story.
Okay, so I presented this this morning in 6pen. We are behind in the schedule, so I try to do it quick, so we have room for the next presenter. So this is regarding the SRv6 O&M draft. I am presenting it on behalf of the co-authors here. Next. So here, I mean, for some illustration, only thing I want you to remember is that blue nodes represent SRv6 capable node, and green represent IPv6, classic IPv6 node that are not SRv6 capable. Next slide, please. Here is a brief history. This work started in July 2019. It was for classic ping or standard ping and trace route in SRv6 network. And then it got evolved when we added SRv6 ping and trace route back in February 2018, or actually December 2017. And we also added cases for segment by segment ping and overlay trace route. I presented this work at last IETF in London. Since then, there was a last call for the 6-pen SRH, for the SRH draft in 6-pen. Out of that last call, there were comments that the OBIT that was defined in SRH draft, it doesn't have the usage for it fully defined in that draft. So we took that comments for the last call and moved the OBIT to this draft. So now it's part of this draft. And also we moved the O&M SID as far as to define the usage. Next slide, please. So the draft actually have sort of two major sections with subsections. So one is defining the building blocks that we need to do O&M in SRv6. And then the second part is about some use cases illustration on how we use this building block. It's not comprehensive, all use cases. People can build something else as well, but that's the basis. So on the building blocks, what it defines is two SIDs. One SID is for punt behavior. So it's called end.op. That's O&M endpoint with punt. And one is for O&M endpoint with timestamp and punt. And then it also defines the usage of OBIT. So the OBIT definition came from the SRH draft. It has been sitting in the SRH draft for quite some time, but we, because of the last call comments, we took it here. But the definition of the usage of it is defined as timestamp a copy of packet and punt the copy of the packet and forward. Next slide, please. On the illustration side of things, there are multiple illustrations. One is the classic ping, which is actually ping to a loopback or IPv6 address in a SRv6 network. And then you have classic trace route, which is tracing a route to IPv6 address in the network. It builds on ICMP, or actually fully use the ICMP. It doesn't add anything, any changes to ICMP, and it works seamlessly with IPv6 node inside the network. For the SRv6 side of ping, it defines a new message type for the SRv6 O&M, and we already talked about that this morning in the 6-pen. But that's the only change, just the message type. In certain cases, the error message that it could be developed by, can be sent when we are using in the context of SRv6 ping and trace route. Next slide, please. So this is just an example where we are pinging loop an IPv6 address B4, which is on the node on that side, and then its ping is happening from B1, but the problem statement is that you want to do that ping via a SID list. So the answer is very simple. The node who wants to do it can create an SRH with the SID list, encode it, ship this packet out, and then any node who's non-SRv6 capable will have no change in terms of processing this message. It's a classic IPv6 ICMP packet, and the node whether include the egress, and in this case egress happen to be the classic node, and then classic node will respond. So no change is required at the transit node or at the destination node, but the SRv6 capable node, who is the source node, wants to do and take the packet over a traffic engineering path, can encode that information in the SRH. Next slide, please. Trace route works the same way. In the interest of time, I'll just skip that. Next slide, please. And this is, again, it is a ping and trace route to a IPv6 address. Now, the second part of the illustration is with respect to ping and trace route to a SID function. And I know there was a comment during earlier as well regarding O&M, I think was from Greg. So SID is considered as generic here. So it could be any SID.
And the ping flavors are there. It's end-to-end ping, where you ping from source to the egress, or a segment by segment ping, where each node in the segment respond to the ping message. So this would be like more like a proof of transit. Okay. And a trace route could be also hop by hop, where all nodes participate and send the response to the trace route request, or it could be segment by segment, where only node that are a segment in the SRH are the one that respond to the trace route. So that's like overlay. And then there is a draft that was part of the chair update that talks about SRMPLS. So this draft is like equally applicable. So it has a statement there, and same is for NS201M, that is SRv6 equally applies to that case as well. Next slide, please. So ping to sit function is basically works very same fashion, but the only thing is that here for ping to sit function, the OTP sit or OP sits is added to SRH, and that causes packet to be carried punted and response to go back to the ingress. Next slide, please. And this, in case of overlay trace or segment by segment ping, we can do the use of the OBIT to force the packet to be processed by the segment on the SR path, and the response only comes from the segment, and the behavior there is forward. Time is time a copy of the packet and forward. Next slide, please. So this draft has been there for almost a year, and it's been stable. And at this stage, we have also, like this is part of the charter, we would really like working group to have an operational draft. We believe it's ready.
Greg has a question regarding the timestamp, and he wants to know when's the timestamp taken and what is the purpose of just having a single timestamp. I think that's his first question. And the second question is with respect to IOM, and his question is, if SRv6 trace route can be used for proof of transit, then what is the purpose of in situ IOM?
So I think the first part is the draft itself does not put a restriction that depends on the hardware capability in terms of where the time is taking. It's going to be up to the implementation, but it's typically as soon as possible on the ingress pipeline. This is where it should go. And regarding the IONM, it's different tool. I mean, the IONM toolkit does provide for prop tracing into the packet, and here we are doing tracing, which is on the probe. So it's different use cases. So there is no overlap as such.
Ron Bonica, Juniper Networks. Could you go back one slide? Easier said than done. Okay. This slide shows functionality that's interesting, not only to packets that have the segment routing header, but possibly other routing extension types, ones that are already defined or maybe ones that will be defined in the future. Might it be a good idea to make this functionality available to everybody by moving the OBIT out of the SRH header and into a destination option that precedes the SRH header? Would have the exact same functionality. It would just be available to other segment routing, other routing header types.
So first thing is that when a node hardware is processing the SRH, the OBIT is there, is accessible, and you don't have to look elsewhere to get another ONM bit, and that's complexity with hardware. The second thing is that here, we really want the node to make a decision based on the SID type, whether that node for that particular SID type really want to process that OBIT or not. It is a local decision, it's still. And with putting it in another destination header makes that complexity too. So I mean, we can take it offline, but I'm not agreeing that we put it in a destination header.
Okay, I'll ask a follow-up question to that. You cited processing time as being an issue. Are you making an assumption that a packet with the OBIT will take the same number of clock cycles to process as one without the obit set.
No, if you put it in destination option, then you have to skip. There everything is SRH, and it's just one bit.
Yeah, I thought so.
Yeah.
Okay, let's talk
So
about it more
that's
offline.
why. I mean, another point is that if you change the very same path that you're trying to do administrator by putting something somewhere that we know that the hardware would have a lower speed in processing, then what are we monitoring? So that's another.
So regarding adoption, we need to sync with 6-man chairs because there is
we
an
had this
extension.
discussion and chair is here. I mean,
Okay, so we'll discuss with the 6-man chairs.
okay. So okay, if this bench here doesn't have objection in proceeding this work, you'd be okay to take that option?
We'll wait for the answers from the chairs, from the 6-man chairs.
Okay.
Because there is an extension to the IPv6 segment header.
Okay. So with respect to time, I know Rakesh is as well there. We have 4 minutes. So
No. Regarding the time, we need to skip the next presentation about counters, as there is basically one slide. Maybe you can make a summary on the list.
yeah, I think for the next slide, to give Rakesh time.
Yes.
I can just say that there's this draft came from SR policy.
Can you summarize on the list? There is one slide.
Yes, I
Thank-
can.
thank
But
you.
I mean, we would like to request working
Yes.
adoption for that
It-
because
it-
that's
it-
been through the review and Rakesh can come while it's coming. But
it-
that has been through the working review during the last poll. So,
It could be part of the email on the list.
okay, thank you.
Thank you.
That's plenty.
Rakesh, sorry, you have 4 to 5 minutes. So you may want to choose one subject.
So I'm Rakesh Gandhi and presenting 3 drafts on performance measurement in next 3 minutes.
You can choose one.
So I'm presenting on behalf of the authors and contributors. So the first draft is for the SR MPLS data plane. Next.
I can scroll down.
So the presentation covers the requirements and scope, the probes for links and SR policies for the delay and loss measurement and the responses and advertising the T-link metrics. Next. So basically 6374 RFC, it's defined for MPLS TP using GAL gas, and we are using the mechanisms that already exist for the segment routing for the links and policies, and as well as the 7876 for the written part. The scope is informational in nature, so it doesn't define new procedures. So as mentioned, this is a GAL gas header for the SR links. The next. And SR policies, we will put the MPLS label stack. Next. So these are the basically the delay measurement and loss measurement packet formats defined in 6374. So next and the next. So out of band one-way delay and loss measurement, the 7876 defines the UDP return path. So this is what we would use for the segment routing as well. The next. And there are already RFCs defined for OSPF, ISIS, and BGPLS is also becoming RFC for advertising the T-link metrics. Next. So we welcome your review, comments, and suggestions. There are multiple implementations already exist, so we are requesting working group adoption for this draft. Next. So this draft is for defining the UDP path for sending the queries, presenting on behalf of the authors and contributors. And next. Next. So the requirement is to loss and delay performance measurement that's agnostic to the data plane, and we don't need to bootstrap PM sessions to negotiate UDP port. That's the spirit of SR. is statelets on egress node, and one-way and two-way measurements and handle ECMP scenarios. And the scope is that we will use the 6374 probe message formats as well as the 7876 UDP reply. So we are basically getting the UDP ports for the delay and loss measurement. Next. So as defined, there is one port is for the delay measurement and one port is for the loss measurement. Next. So response is sent back using the UDP information that's received in the probe query message. Next. So it does define a return path segment list for the two-way measurement. Next. So the SR policy, there is a ECMP. So by adding the IP header, IP UDP header, we can take advantage of the ECMP functions that's already there in forwarding. Next. So we welcome your review, comments, and suggestions. The implementations for the building blocks 6374 IP UDP based pros for IP SLA already exist. So we are requesting for working group adoption for this one as well. Next.
Sue, do you have a question? And then I think we have to cut it.
I'll wait. I mean, he's got a short time and I have just 2 minutes, 2 comments. We need implementation reports on the BGPTE draft. Please, if you've got them.
BGP-LS, you mean?
Yeah, the first presentation,
yes.
The BGPTE, we need those implementation reports to make sure it goes to ISG. IDR has 2 implementation requirements. Thank you.
Okay, thank you.
We're going to call it here because we're already a minute over. So thanks. You can please advertise your slides on the list.
Okay, yeah.
Next.
Okay. So thank you.
Please sign the blue sheets.
Yeah, thanks for the time.